En este video, well, sorry, let's do it in English. This video is about the vertex form of the trinomial polynomial which is y is equal to a times parenthesis x minus h squared plus k, where a is the coefficient. We'll write the trinomial here, plus c equal to y. Yeah. A is the coefficient of the a is the coefficient of the leading coefficient of the trinomial. H is the vertex, and the vertex is a point HK where the line of symmetry passes through. Did I write that true? So, we don't have to, well, let's write the line of symmetry on a Cartesian axis, where this is x and this is y. This points to the positive, that points to the positive, and this is we're going to assume a parabola situated at a certain point where the vertex is this, and normally I write it like this. I think everybody that writes it like that too. So that's the point. The line of symmetry passes through the vertex, and it's the point where the parabola is a mirror image of itself. So you can fold it like this. So this distance here is the same as this distance here. And so each horizontal line are all symmetric. Yeah. So it's important, sometimes, when you're doing this like this, you can find the vertex coordinates and find one root, and you automatically know what the other root will be, because it will be the same distance from the symmetry, the line of symmetry, to the function, the function at the root. This is root, and this is a root. And the root, obviously known as the zero crossing of the function. This is the function of x, which every time we're working with polynomials and trinomials, we like to call it y. But when we work with functions, we have to use this form because we have to evaluate the function in multiple values of x. So we will say x1 will be equal to x1 squared plus x1 plus c. And if I have an x2, it will be equal to x2 squared plus x2 plus c, and so on. There is an x here, there. Let's write it here. Yeah, and this is A, and this is B, and this is C. The coefficient, the x to the 0 power coefficient is C. Yeah, it's written like this. The x is equal to 1, so the x is not shown, but it's there, and then it is multiplied by the x. A lot of the videos I see, nobody mentions this. Nobody ever talks about that. So in any case, I just want to touch all bases with all this stuff. The whole point here is to decipher where this vertex formula comes from. So this is the vertex form trinomial. This is a derivation. I like to make videos about what's behind the formulas, and I will be touching bases with a lot of formulas, and every formula I can think of. In any case, the way we're going to tackle this is we're going to start with a regular trinomial, polynomial, that we're going to set to 0, which is because we're going to assume we are looking for the roots. The main reason to solving trinomial polynomial equation is to find the graphics, and that's it. So we are not finished. When we find the roots, we have to find the vertex. We have to draw the Cartesian plane and put the 3 main points of the parabola and draw it. Yeah. I just want to mention one more thing that it just happened to pop into my head. A parabola that opens up is positive, and a parabola that opens down is negative. And the vertex of each of these parabola have a name, which we call extrema. And this is another extrema. But this extrema is a minimum, is a maximum extrema, max, and this is a minimum extrema. This one here, Sorry about the mess here, but, there's too many stuff in there. But you get the point, okay? Those are almost probably everything you need to know. So to solve this, to get to the derivation of this thing, we're going to use finding the perfect square, which is a method where we find the perfect square, which is a plus b squared, which is equal to a squared plus 2ab plus b squared. These I like to call identities, not used in algebra, used in trigonometry. Well, not used in math, it's used in trigonometry. Like when in trigonometry, like when you have sine squared of alpha plus cosine squared of alpha is equal to 1. This is really, really, really beautiful. Very, very, very pretty. So you could imagine, when you have a circle and you start spinning around that circle, it doesn't matter where you are in the circle, that is always 1. I mean, assuming this is a 1, call it 1 whatever, call it inch or centimeter or meter or mile, whatever. But this is a very nice, beautiful stuff. When you start doing this kind of stuff, but with sines and cosines, which is called trigonometry. It's real pretty, trying to decipher where all these formulas come from. And I'm infatuated with that stuff. This is probably, after doing a lot of math. When I said a lot of math, I mean it, I really mean it, I mean, we talk about math, man. I mean, math, it gets very complicated geometries, you name it, there is a little bit of everything here. And everything is beautiful. It's just fantastic stuff. And I have a whole bunch of notebooks. I got probably 20 notebooks full of stuff. And so I decided that I should make videos, I know that there's a lot of people doing the same thing, and that's pretty, I want to do it too. I just feel like I could do it, not that I want to do a better job, but because some of these guys are really good. I am a talker. I like to speak. I like to talk, and so that's why I go forever and ever and ever. Okay, so we're going to start doing this thing. The first thing we have to do is get rid of the leading coefficient. So to do that, we gonna divide everything by ax plus c over a, and including the 0. It's just because that shows what we do to the function has to be carried everywhere. Whatever we do into this side of the function has to be done to the other side of the function. But this is still 0. So, but doesn't hurt to mention it. Okay, so now we're going to follow the rules for finding this perfect square, which is to find this guy here. Find let me first rewrite this thing. And b over a, so we're gonna leave a space there, and this we're gonna find half of b. I mean half of, not b, but the x coefficient, half of it. So half of that will be b over a divided by 2. We put a 1 here. And this is, you can work it out. I'm sure a lot of you guys know how to do this. You basically flip this guy, put it there, and multiply. I like this double C thing. I never taught in the U.S. this way. The U.S. is taught this way. I learned it this way, which means, you multiply b times 1, and then you divide by 2a. And voila, you don't need, it's same thing, it's just whatever you decide to do is fine. b 2a. That's half of it. Okay, so now we're gonna put it here, b 2a, and we're gonna square it. But because we add this term, we need to subtract the same term. And we have to add A, CA. Okay? So far, so good. I just want to make sure that everything is in place. Okay. So, what else do we have to do? Now, when we get to this point, we can basically write the trinomial as a binomial where the thing inside the parenthesis, and I always keep the stuff inside the parentheses, always write it like this. So in case you have, like, say 5/3, you don't write this thing as 25/9. I never do that. Just never do that. Don't do that, because that if you carry and then put that in here, it will be wrong. So just get used to that. It makes you follow through a lot faster. So b/2a squared, yeah, plus, then we have this mess to take care of, which is I'll put c/a minus b squared divided by 4a squared is equal to 0. At this point, there is something called the GCD, which is the greatest common divisor. So we use the greatest common divisor and put it as the base for our fraction here that we're creating. And then we divide this divided by this. Divide 4a squared divided by a is 4a times c is 4ac. And then we do the same with this one. 4x squared divided by 4x squared is equal to 1 times b2 squared is b2 squared. Yeah, so we can rewrite that here. X plus b/2a squared plus, actually minus b squared plus 4ac divided by 4a squared. And that's basically our vertex. So it means that we have to do something here, because this term, it's non, we should refer to it as the minus b squared divided by 2a, because that is the vertex. I mean, well, I'll show you why I mean that. Because the formula for the vertex is minus, so that indicates that for that to happen, b squared 2a has to be negative, and plus k, and then k will be all that stuff, but in this case it's b squared plus 4ac divided by 4a squared. And that's basically the end. We can take a notch a little bit longer, and we can find the quadratic equation, which the quadratic equation says that x1 and x2 is equal to minus b plus minus the square root of b squared minus 4ac divided all by 2a, which is pretty much, it's almost all there already. So we're gonna finish it. this is the end of the derivation of the vertex formula. This is the formula. Well, vertex form. We call it the vertex form. And okay, so now we're going to solve this to find the quadratic equation. Okay, so what do? We take the square root of this and the whole thing, including the 0. And so, but obviously this will be equal to 2. No, not. Before we do that, I went one step too far. Before we do that, we will move this to the other side. And then let me write this one here. And I'm gonna write it as normal. B squared divided by 2a, but this is not normal. It's just, that's what that means. Okay, so here now we square root here and we square root over here, and this will have a plus minus sign there. Why? Just so like I said, when you have a square root, this will be equal to minus 3 times minus 3, or plus 3 times plus 3. And minus 3 times plus 3 is minus 9. This is 9, this is 9, this is minus 9. And 3 times minus 3 is minus 9. Another extra. So this little problem becoming a whole bunch of extras, which is beautiful. I love it. Okay, so now we have, and we're gonna move it a little bit here so we have space. I hope I'm not coming out of the screen. We have x plus b. Did I put b squared there? You are not supposed to be there. Where the hell you come up with that stuff? I see these problems, I do that kind of too often, Somehow, I confuse b's and I have to be very careful. That's why I learned how to catch these problems. Anyway, so we have now this. I should have erased the parentheses there because it's not there anymore. And this is equal to plus minus the square root of b squared minus 4ac divided by 4ac. Wait a minute. Oh my God, this is wrong. And this is wrong. This is a square here. I'm sorry about that. Like I said, sometimes I do things, but I catch them because I know what the formula should look like. And so when I see some funny thing like that, then you know that you made a mistake somewhere. And I need to make this look like that also. So this is equal to x1 and x2 will be equal to minus b. And we're going to do everything in one shot. We're going to take this out of the square root by squaring the 4 and squaring the a squared. And so we get 2a, which is the same as this 2a, which we're moving over there. So we can basically, because they're the same, we can put all of it in one single line, 2a plus minus the square root of b squared minus 4ac. And voila, we get to the answer. And that's the end of this video. I find that this video is probably one of the best because we do a little bit of everything, you know. You can think of this, how to say, finding the perfect square as finding the factors, you know, because we are really finding the factors. We didn't do that, but that's not the point of this video, not to go through the whole process that you can find on the other videos that I make. You know, I have the graphic way of doing this, of graphing the function. There's the factor way, and then there's the regular standard. This is the standard form. And there is also the factor form. The factor form, it's like it'll be y equal to a times r x minus r and x minus s. This is called the factor form of the trinomial polynomial, this is the factored way of doing it. So sometimes, you know, it's very easy to find the factors instead of trying to get to the perfect square or even following the quadratic equation. Okay, so that's so much for that. 27 minutes, not so bad. This is typical of these videos, about half hour per video. I like to keep it. I like to keep it so much. If it's 50 minutes, it's too short. And if it's more than 30, it's too much. Okay, so I hope you like this. That says form in there. So this is it. Please don't forget to subscribe. If you like this video, say you like it. If you don't like it, fine, say don't like it. You don't have to like it, obviously, and you don't have to share it if you don't want to, you know. But do as you like, okay? No. Thank you for watching, and I'll see you in the next video.